Alright, today we're going to be doing unions, intersection, complements of events, and odds. So let's straight get to this idea. We're going to be discussing about odds. The odds of event E is equal to the probability of event E, all divided by 1 minus the probability of event E, or otherwise known as the probability of E divided by the probability of not E happening. We also typically express this as A over B, or we say A to B, represented by this little colon in between. Also, if we know the odds of event E is A to B, then the probability of V occurring is A divided by A plus B. Alright, so let's deal with the probability of a union of event happening. So let's imagine we got our sample space, we have event A, we have event B, we have 14 elements that are part of A that's not part of B. We have 39 elements that's in the intersection, and with 21 elements that are in B but not in A, and we have 26 elements that is not in the union AB. So if we want to know the probability of A union B, well, this is just going to be summing up all three parts divided by the entire sample space. So this is going to equal to 14 plus 39 plus 21, because that's all the elements that's in the union AB, all divided by all of the elements total in the total sample space all together. And this is going to equal to 74, all divided by 100. Alright, if we were also interested in calculating the probability of A intersect not B, well, first we have to remember that the intersection of A not B is this crescent part of A, all of A that's not part of B. So that is the area A intersect not B. So we're going to have to figure out the number of elements that's in that section, which we already know is 14. We also already know the entire sample space, which equals 100. So 14 over 100 is telling us the probability of A intersect not B occurring. Alright, so let's deal with a deck of cards type example where we have 52 card deck. We are going to be interested in D representing the sample space for all the diamonds, and F representing the events for face cards. So before we start dealing with any probability type things, let's talk about the number of elements that's in the total sample space. Well, if there's a 52 card deck, then there are 52 cards total. The number of elements that's in the diamond set, well, that is just, there's 4 suits in the deck. There's diamonds, hearts, clubs, and spades. So equally divided between those 4, so 52 divided by 4, there are 13 diamonds. The number of face cards, so there is the king, queen, and jack as types of face cards. If there's 4 suits of each, then there are 12 face cards total. If we were interested in the number of diamonds that are also face cards, well, once again, there's king, queen, jack are the number of face cards, and there's only a diamond apiece for all 3. So there are 3 diamonds that are also face cards. And then we would also know D union F. The number that's in D union F would be all that are in D, if you remember the counting principle, all that's in D plus all that's in F minus the intersection, will tell us the union of D and F. So 13 plus 12 minus 3 will equal to 22. So that's the number of cards that are diamonds or face cards. And if we wanted to draw our little sample space for diamonds and face cards, we know that there are 13 diamonds, there are 12 face cards, there's 3 in the intersection, so that means that there are 10 diamonds that are not face cards. Also, there are 9 face cards that are not diamonds. And how many are over here? How many are not diamonds or face cards? Well, there's 52 cards total, and there's 22 that's in the union. So that means 52 minus 22 will tell us the number of cards in the deck that are not diamonds nor face cards. So we'll get a nice 30 over there. So now we can start, now that we have figured out all of this information, we can now figure out the probability of a face card being drawn at random from our deck. Well, if we know that there are 12 face cards total, that is just the number of face cards divided by the number that's in our total sample space. Similarly, if we were interested in the probability of drawing not a diamond, well, that would equal to 52 minus 13 will tell us the total number of cards in our deck that are not diamonds. And that is because there are 52 cards total and 13 diamonds. So 52 minus 13 will tell us the total number of cards that are not diamonds, all still divided by our total sample space. So we'll get 39 over 52, which will give us the probability of not D occurring. Alright, one last example. If we were to figure out the probability of D complement intersect F complement. So remember, D complement F complement is going to be all of the area that's not D or F. So all the not union. So if we have already figured out how many that's not in the union, that's 30. And still we're going to be dividing it by our total sample space, 52. And that's how we can figure out that type of question. Alright, so that does it for today's lesson. Take care.